Okay, hi everybody. So today we're going to talk about quotient rule. Again, this is the updated schedule for the rest of this unit. So the quotient rule is what we do for taking the derivative when you have a quotient in the function. So that means when there's a division. Um, Again, we have to deal with continuous and differentiable functions. Otherwise, we can't take the derivative. And then the other kind of issue is that g of x, the denominator cannot be zero. So if there's a place where the denominator is zero, then that means that we won't be able to take the derivative of that spot, which should make sense because we're just dividing by zero in that spot. And so then we don't have continuity. So this is the quotient rule. You should write it down in your notes. This is the big formula. This is the main thing that you need for the day. There are a couple of mnemonics that will help you remember it. And so I always say bottom d top minus top d bottom over bottom squared. But if you want low d high minus high d low over low squared, that's fine too. Other people just say bottoms up, so that helps them remember that you're supposed to start with the bottom function, the denominator. Um, this is quite tedious, honestly, and so you're just going to have to kind of deal with that as we go. Couple of examples. The first one we're going to do is tangent. Remember that tangent of x is just sine over x, sine of x over cosine of x. So if we do the derivative with respect to x of tangent of x, then that's just the derivative with respect to x of sine of x over cosine of x. And so that means we're doing bottom d top minus top d bottom over bottom squared. So let me just rewrite that. Bottom d top minus top d bottom over bottom squared. Okay, so it is cosine of x times the derivative of sine, which is cosine of x, minus the top, which is sine of x, times the derivative of the top, excuse me, of the bottom, excuse me, which is negative sine of x over cosine of x squared. Let me just color code what I have here. So bottom d top minus top d bottom over bottom squared. Okay, and so then we just simplify, which is equal to, so this is cosine squared minus sine squared, sorry, plus sine squared over cosine squared. And I know Pythagorean identity, this numerator is equal to 1. So it's just 1 over cosine squared. And so 1 over cosine squared is secant, cosecant. No, secant. So there's our derivative of tangent. All right. This one is a rational function where the denominator is never 0. So that's kind of nice because we won't have to deal with any spots where that's an issue. So bottom d top, all right, q prime of x is equal to bottom d top, which is 5, minus top d bottom, which is 2x over bottom squared. So I'm going to rewrite that x squared plus 1 quantity squared. I'm going to do a little simplifying here just because I want to explore where that might take us. It's not necessarily going to make it any simpler. It's just worth trying. It's good for our algebra skills. So q prime can be rewritten as 5x squared plus 5 minus 10x squared minus 4x all over, and then this would be x to the 4th minus plus 2x squared plus 1. The numerator can just be, there's a couple of like terms here, so we just have these two. So we can add those. Q prime of x is equal to negative 5x squared minus 4x plus 5 all over x to the fourth plus 2x squared plus 1. Obviously, this is not like an easy thing, and so have patience with yourself. It'll be all right. This is sort of a logical leap. It's just jumping to what the derivatives of these reciprocal trig functions are. And so these cosecant, secant, and cotangent formulas are new. We can do them by doing the quotient rule. And so I think I would encourage you to try doing the quotient rule on cosecant, secant, and cotangent, and verifying that these derivatives are real. So that would be the next thing to do in your notes. I'm not going to make you memorize them this year because it's May, but I will next year. Okay, last problem for the day is just to differentiate these two functions. It's actually the same function, but just two different ways. The first way would be using the quotient rule, and the second way would be using those shortcuts from the previous screen. So y prime equals bottom d top. So the derivative of negative cosine, the derivative of cosine is negative sine. So the derivative of negative cosine is positive sine, minus top, 1 minus cosine of x, d bottom, which is cosine, over bottom squared. So let's see where this takes us. Um, it's sine squared y prime equals sine squared minus, and then distribute the cosine in, so we get cosine x minus cosine squared. Oh, sorry, plus cosine squared over sine squared. And so then that gives me factor out the 1, because I got a sine squared plus a cosine squared, so I can make that a 1. So there's that. And then I guess I could do, what else could I do? Rewrite it as 1 over sine squared minus cosine over sine squared. Yeah, this is going to take us where we need to go. And so this is going to be cosecant squared x minus, and then I've got a cosine x over sine squared sine x, and then times a 1 over sine x. And so this part right here is going to be a cotangent, and this part right here is a cosecant. So my final answer that way is y prime of x, no, y prime equals cosecant squared x minus cotangent x cosecant x. I guess I could factor out a cosecant, but I don't love that, so we're going to keep it like that. The other way would be to use the shortcuts from the previous screen. And so the derivative of this is negative cosecant x tangent cotangent x. And then the derivative of negative cotangent would be plus cosecant squared x. And so we can see that the two representations that we have are equivalent right there. I've got this, I've got this. They're the same, just in different orders. I don't have a strong preference. Either way is fine. Either you're going to memorize the identities, or you're going to be able to do it directly using the quotient rule. Both ways are fine. I'm going to post a homework assignment on the document for today, and then do that out of the book, please. See you Monday.